in binary. So negative numbers in binary. So because it is important, right? So in base 10, so definitely you are able to show the negative numbers, right? You say, okay, whenever I have positive, I usually use this. Whenever you want to represent negative, you actually use this negative sign here, okay? So negative 10 is another example. So the question is, because we don't have these negative sign, we couldn't put negative 1, 0, 0. It is wrong, okay? You couldn't say negative 1, 0, 1. It's not means negative these number, okay? There is some other methods that you need to use to actually represent negative number in binary. See, there is actually 3 different methods. So here we start to mention to each of them. So the first actually method is using the sign magnitude representation. So let's see what it means. So I write the method name here, which is the sign magnitude representation. Okay, so let's see how we could use this method to represent the negative numbers in binary. So the answer is the bit that you use on the left side of the number, it's not actually the number. Actually, it's used for showing the sign. If that's actually the positive, it means it is a negative number. If the left bit is actually 0, it means you mean actually positive. Okay. For example, you want to show negative 3 in binary. Okay. First, you tell me what is the 3 in base 2 if I want to have 3? So 3 is 1, 1. You could add any 0. For example, here I consider it 4 digit. Okay. This is actually the 3 in base 2, right? Base 2, this is 3. So if I want to represent negative 3, so maybe that's better to write this. So this is positive 3, right? So if you want to show negative 3, so again you use the same thing, 4 bit, which is the 3. So the bit that you have on the left side usually is showing the sign, okay? So if you want to, for example, here say negative 3, so definitely you need to put 1 here. And if you want to represent positive 3, so definitely should be 0, because 0 means positive and 1 means negative in sign magnitude representation, okay? So just consider this is not counting to these numbers. So don't tell me this number is, so see, technically you could say 1, 2, this is 4, this is 8, this is 16, right? Don't tell me this number is 16 plus 2, which is 18, 19, okay? Because we never count the left side as a number. This is just a bit that we use to know about the sign, right? So this actually tell about the sign. So the both of them is 3. This one is positive 3 because this left bit is 0. And this is again is 3, but negative because this bit is 1, okay? So based off this, if you have your number is just 4 bit, use 4 bit, okay, 4 bit numbers, and tell me I want to represent negative 7. Tell me how you could represent negative 7 with using the sign magnitude representation method. Tell me a bit pattern which is represent the negative 7. Again, use 4 bit. So that means 4 bit for the number and the last bit that you have on the left for the sign, okay? What is the -7? If I want to use this method, how I could represent -7? One, one, one. Yeah, that's right. So you say, okay, first you need to represent 7 with 4 bits. Forget about the sign. You say 0, 1, 1, 1 is 7, right? So then you say, actually, yeah, if you just say 3 digits, you are right. It should be 4, 1. But because I mentioned 4 digits for number, first you need to represent the +7 with 4 digits, then add 1 bit on left, which is tells it is positive or negative. So negative is 1, so this is actually is 1. If you want to show +7 is the same thing, this one should be 0 and 0, 1, 1, 1. Okay? So this is actually is about sign magnitude representation. Any question about this? Usually somehow you tell your compiler your number is signed or unsigned. I don't know, have you ever worked with the C or C++? Whenever you declare any number, usually you have different data type. You have signed, unsigned, which is somehow you are telling compiler don't care about these kind of the stuff. The old number is unsigned. We don't have negative, but whenever you say sign integer, for example, that means you are telling we care about these kind of the situation, right? So this is actually first method. We have two other methods to represent negative number in the base 2. So let's see the next one. So the next one is number 2. So number 2 is ones complement form. So that means the one, that's why you actually learn about them. Ones complement form. To see how you could use ones complement and represent the negative numbers in binary. So example is this: if you want to represent -3, first you need to represent +3. So +3 is with 4 digits is 0, 0, 1. So then if you want to represent -3, you just need to take a first complement of that, okay? So, or here I write the ones complement. So you tell me what is the, if I take the ones complement, definitely that should be representation of -3. So you tell me what is the ones complement of this number? One complement of 0, 0, 1, 1. We learned about that in today's class. Yeah, definitely. Convert the 0 to 1, 1 to 0, easy, right? So 2, 1 should be converted to 0, 0. And the next is 2 would be 1, 1. So that means if you want to use the ones complement form to represent negative number, whenever you want to represent negative number, first write the positive of that, which is +3. So then you actually take the ones complement of that, which is this number that you see here, okay? So let's have one more example. So I want to represent -6, okay? So I give you 1 minute based on what explained here. We want to use ones complement form and represent -6 with the binary numbers. Okay, let's see. So first, you say I need to represent 6 with 4 digit. What is the 6 with 4 digit? Is let's write this. First, step number 1, +6. What is the +6? So which is 6, which should be 0, 1, 1, 0, right? This is 6, why? This is 1, this is 2, this is 4, this is 8. 4 plus 2, you have 6. So then takes actually the first complement, right? So what is the first complement of these numbers? Change 0 to 1, 1 to 0, right? So I'm writing here. Maybe do this. So the first complement of this is I start from here 1, 0, 0, 1, which is what I did. Just take the first complement. 0 change to 1, 1 change to the 0, okay? So whatever you got should be -6, okay? So let's go to the third one, which we have the third method, which is the using the very similar to the number 2. So number 3, third method to represent the negative number is the 2 complement. 2's complement 4. So that's clear from the name, right? So this time again, similar to 2, in the 2 you write the positive number, so then takes the first complement. Here you write the positive number, then takes the second complement. So let's do, suppose each number shows with the 4 digits, and I want to represent -5, okay, with this method, okay. So the first thing is find the +5. What is the +5 with 4 digit? With 4 digit, you tell me, what is the 5 with 4 digits in the binary? 5 in binary with 4 digit. So yeah, 1. You see, you should, yeah, 0. That's right. So 0, 0, 0, 1, 0, 1. This is 1, this is 2, this is 4, and this is 8. So this is 4 plus 1, which is 5. So please start to work on the homeworks that you have, okay? So you need to actually have more practice that we actually be more comfortable with this concept, okay? So this is 5. So I want to get -5 using the 2's complement. The only things I need to do is to take the 2 complement of these number. What is the 2 complement of this number? Which is give me -5. What is the 2 complement of this? Or you could get the 2 complement of this. So that's today's, actually not today's, probably our last class lecture, right? For getting the 2 complement, first keep the non-zero from the right side. So non-zero from the right side, this is 1. And the others 0 to 1, 1 to 0. So this should be 1. This should be changed to the 0, and this should be again 1. Okay, so that's the 2 complement of that. So that means -5 should be actually 1, 0, 1, 1 if you use 4 digits, and if you use 2 complement form to represent that negative number.